We'll first discuss the solution of the midterm exam, and okay. See, the first problem uh, was something similar that you solved in the class test. Uh, we had 192 users uh, with a spelling factor 256, and the rest are using 128. Okay, so thereafter the change occurs. So since these 192 are using 256, at this level 256 codes are available. Uh, so the users with some other spelling factor uh, can have 64 at 256 level. There can be 256 nodes. I mean, at this 256 level. So at this level, 64 nodes are available, but the actual spelling factor is 128. So half of them will be actually the users. The number of users will be 32. Okay. So the total number of users are then 224. Okay. And half of these total users, okay, I mean, when the change occurs, half of the total users start using spelling factor 512. So the, I mean, 112 users start using 512. Now at the level of 512, there are 512 codes available. And so if we deduct 112, we have 400 codes available at this level. However, for all others, the spelling factor is 32, not 512. And so the ratio between them is 16. I mean, it's 2 to the power 8, it's 2 to the power 5. So the ratio is, sorry, it's 2 to the power 9, 9 and 5. So 2 to the power 4, 16 is the ratio. So actually we have to divide 400 by 16 to find out the number of users at the level of 32. Okay, so if we divide, then the number of users we get 25, and we had at 512 120 112 users. So the new number of users are 112 and 25 137. Okay.
Sir, if will there be any partial marks applicable if we are correct up to
Yeah,
a certain level?
yeah, definitely there'll be
Okay.
partial grading.
Yes. No, sir, I corrected up to the last step successfully, but in the last
Okay.
line I mistakenly wrote 7
uh,
instead of
okay
22.
okay and then the second question, I think most of you might be able to answer. I mean, the scaling code determine, I mean, sort of descriptive. Uh, why are, and short description should be enough. Why are PSS and SSS are located at the center? Okay, because you have to first, uh, I mean, you had no idea of the bandwidth before synchronization. Okay, the bandwidth the particular operator is using. And we also said that you can uh, scale the bandwidth in uh, in in time. And so all these are possible when you have the part of the bandwidth that you used to first that you used for first detection. The UIs first capture the synchronization signal to recognize that there is an operation going on, and also it finds out the identity of the cell. Okay, it synchronizes. So it I mean, when we discuss the first step, okay, PSSS, then we also discuss that it confirms the ERFCN, that's the center frequency. Okay, so you it finds out some energy when it does the frequency sweep, but it confirms that there is an LT operation. Okay, so it is centered. The synchronous signals are centered uh, within the whole bandwidth. Okay. The fourth question was uh, not difficult. You the timing advance command. Okay, you send to adjust for adjustment. When it is positive, then of course you have moved further away, so you increase the timing offset, and it it's negative, so we have got closer. Um, but it's round trip delay, as we showed using the figures. So you first have to divide it by 2. Okay, then you can find out the corresponding distance, uh, the distance by which you have changed your position. So the previously it was 500 meters. So the new position will be like this: 2,967.5 meters. Okay. The next question is even easier. Okay, I mean, I gave it just for people who, I mean, for people uh, who are relatively weaker. Okay, so if you increase the maximum possible radius to 140, it is 100 kilometer in LT, and in that case we did a calculation that is 0.67 millisecond. So when you make it 140, okay, of course, I mean, you have a 40% increase in the distance. The uh, I mean, timing offset requirement will linearly increase. Okay, so let's multiply by 1.4 and you get the answer. Let us take a break for our Asr prayer, and we will be back at 4:10. But I'm not sure, but I mean, I may be a couple of minutes late. Okay, I hope to be there on time. Let's see. so on. So let's resume our discussion.
জি স্যার। আর 2টা মিনিট পর দিলে স্যার মাত্র 29 জন আসছে।
Okay.
Sir, I had a question, sir.
Yeah, please go ahead.
Sir, in the question number 3, if you can show it again, the question number 3.
Yeah. Yeah, what's your
Sir, it
question?
said that what are the PSS and SSS channels located at the center of the bandwidth?
Yeah.
Sir, according to the lecture, it's been given that to accommodate the 5 and 5 DTX cycles at the in the subcarriers, we have to keep the PSS and SSS at the center of the 72 total subcarriers. Okay, sir. So that we can accommodate the 5 and 5 DTX cycles too. So if someone writes like that way, because it's given in the slides regarding that.
Yeah. I could not hear you very well. Could you please repeat what the reason? I mean, what the text says? Just please repeat that
So I
part.
was talking about the DTX cycles.
Okay. DTX. Well, in fact, it see the minimum. I use when we are discussing about its location. We said that the bandwidth can be scaled. It can be 1.4 megahertz or 3, 5, 10 megahertz. But the minimum 1.4. So it may happen that someone starts with 1.4 megahertz. Later he increases the bandwidth. He increases it to 5 megahertz. He can do that. But it will always be located at the center, and it takes up the frequency range it takes up is equal to the minimum bandwidth 1.4 megahertz, where you have 72 subcarriers. Okay.
Yes, sir.
But the way you generate the sequence, when you generate the sequence in the using
Sir, I said that to keep the 5 and 5 DTX cycles at the end of the subcarriers, we need to put it in such a way that there are 5 tailing and ending 5 DTX cycles, so that it fits in the 62 carriers. Okay, sir, within the 72
yeah,
ones. So that's an
yeah,
explanation given in the lecture.
yeah, that explains how you organize the DTX. I mean, the DTX, if people avoided the DTX, these PSS and SSS would still take up the center of the bandwidth, even if you did not have DTX. Okay, you
Sir,
have
is
DTX
there
because the bandwidth it takes is set equal to the minimum bandwidth of whole LT operation, which takes up 72, but you require 62. So you put put what you use at the center and put the other. On other subcarriers, you use no transmission. That's how you have DTX. There is no okay.
sir, is there any
But
relation with the orthogonality? Because for orthogonality, we need the frequency to be located at the center because there is no intercarrier interference.
No.
interference of other subcarriers.
No, orthogonality is already maintained. I mean, there are two types of orthogonality. Orthogonality, on one hand, you have orthogonality among the subcarriers. Okay, that's what we showed, that you have zero power at the adjacent subcarriers. The other type of orthogonality is what you have in the code sequence, the PSS sequence or SSS sequence. These sequences have orthogonality among themselves. Okay, but it's a
So
sequence in
comparing
the
with
frequency
DT,
domain. Mhm.
so comparing with the DTX correlate that I said earlier, so it won't be any good because that's also a cause of why it's at the center. It's of carriers.
Well, that's not the major cause. As I said, that if you did not have DTX, if your code length was 72, I mean, currently the code that it uses, PSS or SSS uses, is 62 sequence, 62 points long. But if you had used a code that is 72 points long, you would still set the 72 at the center of your whole operation. Your whole LT could use 1200 subcarriers. You'd still set this 72 at the center of the whole 1200 range. Okay, it's because the EV will first capture, and then it identifies the bandwidth, and the bandwidth can be scalable. The bandwidth can be scalable. The specification sets this in a way that it provides for easy scalability. Okay, scalable. It is easily scalable. Okay, so if you start with 1.4, you set it there. If you now scale, you say scale increasing your bandwidth in on both sides. Got it? So it is always at the center. Okay. Then why PC FSH is distributed in frequency? I touched upon it in the class that it is split into 4 parts, so that if you, on some frequencies, there can be sudden noise or interference, so you can lose a part of it. On some frequencies, the detection can be wrong, but if you have other parts of the information at other frequency locations, which you may be able to detect correctly, that can help you actually recover the whole thing. Okay, actually it's a because of coding, and it uses block code, the easiest form. Okay. So even if you lose two, it is split into 4 parts. Even if you lose 2, it will be able to detect from the rest 2, but it's indicating whether 1, 2, or 3. Okay. And my book shows how how the block code is used there. Anyway, so this frequency diversity, you use in the frequency domain, you use diversity, you distribute your information at different frequency locations. Okay, to because there can be sudden interference on some frequency. For some user, some neighboring cell may use some high power, but later the power control settles. Okay, so suddenly in other cells are then adversely affected at those frequencies. So in cellular environment, information very commonly get lost at certain frequencies. Okay. Now compare IMSI and CRNT. Well, IMSI is a fixed identity, whereas CRNT is a cell-specific identity. As you move to a different cell, an RC connected state, if you don't have any data session or call up, then you are not in RC connected, you are in RC idle mode, and then you are also not assigned CRNT. Okay, IMSI is fixed whether you are in RC ideal or RC connected. You have you have certain IMSI, and it is actually inscribed in your SIM card. But here CRNT is uh, assigned when you get or when you move to RC connected state, and also if you change yourself, a new CRNT will be allocated. The CRNT changes. Okay, so it is cell specific. That uh, letter C comes from cell. Now, the reception of a correct data packet can be late in the case of NRT compared to real-time applications. Right? On all the possible reasons for this delay. Well, a major cause can be the the additional correction in the upper layers. We discussed that you have packet retransmissions for correction effort at different layers, but all these layers are not used uh, in both cases. Okay, only uh, uh, 3 layers are used when you are in NRT applications. Okay, HRQ, MAC level, HRQ, then you have retransmission at RLC, and then you have TCP. Okay, so when you find a packet incorrect, you send a feedback that you haven't received it correctly. The packet will be retransmitted. This causes some delay. Some calculation of this delay we discussed for HRQ. If you have 3 retransmissions, then you see that you have 8 millisecond delays, typically 8 millisecond delays for each of the retransmissions. So when you go for this correction, the eventually the correct packet received after this delay, if you use all these 3 retransmissions, then there are additional 24 millisecond delay for the correction of this packet. Now, if the packet is still incorrect, then it will be forwarded to, MAC will not take any further action, but RLC will do. RLC will again send feedback, and there will be again retransmission at the RLC layer. So that will cause additional delay. And if you again have some wrong detection, okay, then TCP, wrong reception of data, then TCP will perform retransmission. So you see, the retransmissions cause some delays, okay, but in the case of RT application, you don't care. There are packet transfer, this delay at the upper layers are not there. Okay, you have incorrect reception, you leave it there. Okay, you just leave with the uh, wrong packets. Okay. Then 2G and 3G do not have semi-persistent scheduling option. Give reasons. Well, you had their circuit switching, so you have reservation of the resources. You book the resources uh, for the whole session, so there is no overhead for scheduling. Okay, so you don't need, but in 4G you don't have CS, so to avoid the overhead of scheduling again and again, you use semi-persistent. Now, this question, do you have any questions? Okay. Now, in this case, you first assume that we have equal period for all the symbols. With normal, by normal circuit practice, I mean that you have 7 symbols in a slot. Okay. So just divide it by 7. So 0.5 divide by 7. Okay, and the control region is 2 symbols period. Okay, so the control symbol region will be 0.5 by 7 into 2. Okay. So this is the length of your control region. Okay. Now the total delay, okay, up to I mean from the reception of your PDCCH. Once you get PDCC, read PDCCH, then you know that there is an allocation. Okay, from there you start preparing your packet, and then you transmit your original, and then first, second, and third retransmission. So it says uh, that you should calculate the time gap until you begin the third retransmission. Now we know that I mean uh, when you begin your first retransmission, okay, then uh, you you can add another 8 milliseconds to find out when you begin your second retransmission, and then third. Okay. And in fact, the first retransmission is also 8 milliseconds away from the original transmission. So there are always 8 millisecond time gap, and it is fixed in the case of uplink. Okay, it is synchronous. I mean, you have always 8 millisecond time gap. So once you find out when you begin your original transmission, you can just add 24 to that. Okay, 3 times 8 milliseconds to find out when you begin your third retransmission. Now, to find out when you begin your first retransmission, there are 4 subframes delay. We know that from the allocation in terms of numbering, you have 4 subframes delay with the beginning of original transmission. But you need to first subtract this part, okay, the length of the control region, and also the timing offset brings the two things closer. Okay, the PDCCH you receive actually later, say compared to when you transmit. I mean, your transmission of say subframe 1 is 2 times propagation delay, twice of your propagation delay earlier compared to your reception of subframe 1. We explained it in the case of uplink synchronization. So when you consider the subframes with the same numbers, your transmission, I mean by your transmission I mean the transmission from the EV end is twice as much as propagation delay earlier compared to the reception. So the propagation delay is 0.1 millisecond. So you also need to subtract 0.2 and this part. Then you get the time gap between original transmission when you begin your original transmission and when you complete listening to the PDCC. Okay, therefore you add 24. Questions?
No, sir.
Now for downlink data transfer, we discussed that packet 1 is transmitted and the retransmission takes place for packet 1. But in between, you have another transmission of packet. Packet 2 is also transmitted. Okay. Now,
So
for
when can
downlink,
we practice problem? Where can we practice problems like this? Sir? If you could give us some appropriate resources.
this
This-
this is a
the
question.
solves are making us very depressed, sir.
This is a question that I don't know if it is a planned question from your end.
Sir, because sir,
This
in
is
other
the-
questions we get some alternatives, sir, because we have some alternatives like from 3 out of 4 or 4 out of 5. But in this exam, we had to answer all of the questions in a limited time, and which was also not as usual questions. So I think the grade will be disastrous, as we have seen, sir.
Sir, if you compare the questions of this mid exam with the previous ones, I guess you can see a difference. I guess this one was a bit more hard.
Sir, while I was preparing for the mid, I was also solving the last year's question, and I could solve them easily.
Yes,
But
sir, same.
when I faced this question, like, it was a total shock.
Really? Okay. Okay. Let's see. Well, the questions we have discussed so far are, I mean, tell me which of them, which one is difficult? This one, is it difficult? I mean, similar problem you solved in the class test, and if I followed my solution, uh, but anyway, I mean, I mean, when you really sit for an exam, I mean, things can look difficult. Let's see. Well, you know that I scale. Okay, that probably will probably help. And I mean, everybody has got the same question. Okay, so there is at least fairness. Okay, among yourselves. So if I scale, then that will probably take care of I mean, anything you might lose otherwise. Okay. The reason I did not use any extra questions, okay, from which I mean, some option for you to select. We can do that in future at the final exam. We can definitely do that. But you know what? I always experienced while I was at Virginia Tech with questions with no, I mean, additional options. Okay, just all the questions I had to answer if I could. So, and that I felt comfortable with that, because that was also my impression that one should be. I mean, every question has a target that I try to adjudge the students with this question. But if I allow him not to answer, then I cannot use this tool for this purpose. Okay. But anyway, let's first see how you have performed, and then we'll try to rationalize. Okay. Okay. Then in this question, well, now let me tell you why the question is little harder than the previous year's question. In this case, the exam was open book, and I mean, you have I mean, because of online exam, I had to allow that. Okay. So if I don't use some challenge in the question, okay, then it becomes funny. If you can just copy from the source, then it makes no sense. Okay. So at least to some extent, every question did not have the same level of difficulty. I use different level of difficulty because there are also students with different I mean, level of strength. Okay. But anyway, let's see. Let me first grade, then I'll try to take care of it. Okay. And some new challenge. Okay, I also wanted to introduce here, say, especially the last two questions, I wanted to introduce some new channels. So because there has to be something new. So you might have all the solutions of the questions of the previous years ready uh, be, before you when you sit for the exam. Okay, and you can quickly solve similar questions. But if there is something new, then there can be fair judgment among the students. Okay, in the case of open book exam, especially, I mean, when we had open book exam, we got more scared. I mean, in USA, I found that i- open book exam, people are more scared with open book exam, and they're even more scared with take home exam. Take home exam means the teacher just gives the question, and the students have to solve it and submit it after a few days. So he has access to all kinds of resources. Okay, but it's not allowed to communicate with any other person. Uh, but in this case, if it is take home exam, then the question is darn difficult. Really, I mean, too difficult. Okay, so the difficulty level changes when you have uh, more liberty. Okay, in the environment of the exam. Now, see, the downlink allocation uses resource block assignment. Okay, some value it is using to locate the resource blocks. NDI has a value and modulation scheme. It indicates the MCS. Okay. Now, before you retransmit, there is a transmission. There is an additional transmission in between packet 2. Okay. Also, in the case of retransmission, you use a different modulation level. How do you I mean, uh, in the case of retransmission in downlink, you can use a particular modulation order. Okay, we discussed it. The modulation can be just indicated that use this modulation, and also you can indicate the redundancy version. This over these two things you have control. Okay, you can change at the time of retransmission, and the resource block positions can also be changed. Okay, so we discussed actually that these three things you can change. So I mean, resource block assignment, whether it has to be X or it can be different, it can be different, it can be different. Then you can see the screen, right? The the screen is visible, right?
Yes,
And the
sir.
questions, yeah, okay. Now about NDI, you see the NDI value toggles when you have a new transmission, but if it is a retransmission, then you don't toggle. So after packet 1, packet 2 is transmitted, and that's a new transmission. So from 1, it will toggle to 0. But after this packet transmission of packet 2, you have a retransmission for packet 1. So in that case, it won't further toggle. So it keeps 0. NDI remains at 0. Okay. Then what is the value of modulation and coding scheme? We discussed that when you change the modulation order, the last few values of MCS are used. I mean, in the case of retransmission, the last few values of MCS field are used to indicate the modulation order. And if you support up to 1024 QAM, then the last 5 values are used for this purpose. If it is if you support up to 256, then the last 4. If you support up to 64, then the last 3 MCS values are used to indicate the modulation order for retransmission. Since it is 1024, okay, you have the last 5 values. That doesn't matter actually what I mean, the highest value 31, okay, you use to indicate 2024. Okay. So after 0 to 26 are used for, I mean, in this case, are used for new packet transmissions to indicate the MCS level for that. HARQ ID, this field you need because there can be multiple retransmission processes. Say this packet 2 could have also some retransmission processes. So these retransmissions, okay, different flows of retransmissions are separated using the HARQ ID. So it exists. Does the field redundancy version exist? Yeah. You also need this value in the within the PDCCH for your retransmission to indicate what RV you are using for retransmission, and it is RV2. So you are using, it is indicating RV2. Okay, actually it is set to 10, the field in, but that you don't have to write down. If you just indicate that, if you just write down it indicates RV2, it's fine.
Sir,
Yeah.
for the first question, the x value, you have the answer is it can be different. So if we write any specific value, so will that answer be granted, like x plus 12 or something? We assume that there is a retransmission, and for those we some of us showed some answer x plus 8 or x plus 12 something, which indicates that yes, it's different. So will that answer be granted, sir?
See, when you write down x plus 8, then you are definitely confused with
X plus
the
12, sir, in this case. I
x
think
plus,
x
x
plus
plus
8 or x plus 12 in this
x
case.
plus 12. When you write down x plus 8 or x plus 12, then you are definitely confused with the timing. I mean, between timing and the resource block allocation. The
Yes, sir.
RBs, I said that the RBs are allocated. They take up different positions in the within the frequency domain, and it's up to the E node B where you allocate. For any user at any time, you can allocate any RBs. Especially for downlink. Okay, RBs it can be allocated, but about timing of these subframes, there are uh, certain time gaps, okay, that you have to maintain, like 8, 4, sometimes 4, then 4 plus 4, 8, or 12, whatever. Okay, so that's no way related to how you are organizing your RBs this time. These RBs you you could locate anywhere. Okay. So it's not just, you can say that it can be different, but what it can be is up to the It can be, it can take any position. Okay. Anyway, now for the next question. In the case of uplink, I put them side by side to check whether you could understand the difference between the allocations for downlink and uplink. The resource block assignment is Y, NDI value is 0. Okay. Oh, sorry, it is just 1 here. And modulation is 21. Okay. Now, when you are retransmitting, you are again using PDCCH. Okay. In most cases, people, I mean, this it is not used that way. PDCCH is not used for retransmissions in most cases. Okay. But in this question, you are using. When you use PDCCH, you can change the resource blocks, or you can change the redundancy versions. These two things you can change. Okay. But the modulation order you cannot change. Okay. And also you have some fixed timing. The time gap is always 8 milliseconds. So you know, whenever you get PDCCH at certain subframe, then you can actually recognize that it is for a particular HARQ process, for a particular packet transmission flow, just from the timing of PDCCH, because it will always maintain the same timing, same time gap. So that is why HARQ ID is not required. The different packet flows, transmissions, retransmissions for a particular packet, and then for another packet, these different flows of correction procedures are already identified their timing, which subframes they are using. So HRQ ID is not required in uplink. Okay, so HRQ ID is not present in the case of retransmission. Okay. The new PDCCH will also not require redundancy faster. You are indicating, in the case of retransmission, you are indicating that you want to use RV2. You want to use RV2. But to indicate this RV2, you don't have to use uh, any field, any redundancy version field in PDCCH. This, sorry about that. Now, the first question is whether the resource block assignment field uh, has to retain the value of Y or it can be changed. So in the case of retransmission, when you are using this PDCCH for uplink, then it can change. So it can be different. Then the value of NDI, it works the same way as you have for downlink. You had 0 for packet 1, urgent transmission of packet 1. Then for packet 2, it's a new transmission, you toggle. It toggles to 1. And thereafter, for the retransmission of packet 1, you don't toggle again. Okay, it does not toggle. So it is 1. It retains the value of 1. Then the value of modulation and coding scheme. This part is tricky. You use the last 3 MCS values in the case of uplink. Okay, last 3 MCS values for the purpose of indication of your redundancy version. If the redundancy version is 1, you use 29. If it is 2, you use 30. If it is RV3, you use 31. The rest of the MCS values are used for new packets, for new transmissions to indicate the MCS there. But the same modulation order you have to use in the case of retransmission. Although you are using DCI, format 0 again, PDCCH you are using again, but it won't change the modulation order. Okay, so the MCS now indicates, it does not indicate actually MCS, although it is the MCS field, but it does not indicate modulation order. It indicates redundancy version and indicates using the value 30. Okay. So I think I have already explained all these 5 questions. It can be different. 1, 30, HARQ ID you don't need, and RV field you don't need in the case of uplink. DCI format 0 does not have redundancy version field. Okay. The last 2 fields it does not have. Okay. Please give me a second. Okay. So with that, we complete our discussion on midterm questions. Do you have any questions? I know you have grief, but with the, I mean, I already explained why the question has been deliberately made little harder, or I added some challenge. Okay, the challenges are also little different. Okay, the challenges are like uh, different in the way that you you have the challenge, although you have all the uh, discussions, all the lecture notes with yourselves. Okay, you still have to work out. Okay, so let us begin our discussion today. We started discussing DRX, and in fact, also I mean, in the last semester, we also spoke of it a little bit. Okay, and there is also an extension to DRX in 5G eDRX that we'll discuss later. 5G features we'll discuss later. We need to really rush. Okay, I'll try to go faster because we have to cover a lot of things. From 5G, I wish to cover uh, a good part. Okay, now uh, the DRX cycle we explained, and the DRX cycles can be uh, are, I mean, they have different types of operation in RC idle case and RC connected case. Okay. So they are shown differently. Okay. Now, when you have um, idle mode, then uh, okay, the device turns on here, the on period, okay, and this is the off period. In this case, in RC idle state, you may receive a call from the other end. Okay, if it is you who are making the call for voice call or for some data sessions, for example, if I in the case of video call, okay, it's a data session. You may be making a call or you may be receiving the call. Uh, so for voice call or any data session, if you are making a call, if you want to make a call when you are here, okay, then it's very easy to change your mode. You just turn on your device right there. Okay, right, right then you turn on your device. Okay, and then you perform all the operations you need. Okay, you'll do that. So the on, okay, you turn on here when it is you who wanna make the call. But if you are receiving the call, then you have to you are sleeping, so the base station, the network side, has to notify that you have a call to receive. Okay, and the base station cannot do that because you are not listening to the base station. So the base station waits until you again turn on. In here, the base station notifies. This notification that you have a call or data session, whatever, to receive, and so the base station notifies you. This notification is called paging. We'll have little more detailed discussion on paging. But for paging also, uh, you see that you can only do that when you are in the on period of DRX cycles. So how often you can send your paging page, you can send pages, okay, or you can perform paging. It's called paging cycle. So in fact, this paging cycle and the DRX cycles are equal. Okay, so it turns out that paging cycle is equal in length to DRX cycle in RRC idle. In RC idle mode. Okay. Okay. Now we'll discuss our DRX for RC connected state. In connected state, you already have some data session up, and in this case, you have some packets coming in. Say one packet comes in here, and the packet. But some after this packet reception of a packet, you find that there is a, I mean, there is the gap in packet transfer because in PS environment, okay, the packets are generated from the source uh, depending on its necessity, and sometimes there may not be any packets for a while. So at the receiving side also, you find that there is no packets coming. There are no packets no packets coming in for a while. So why you keep powered on and waste, drain your battery? So you still wait for a while, and I mean, when you find that there are no packets, you wait for a while, and then you go to off mode. Okay, you turn off your device. So you start actually DRX operation. This is a DRX operation RC connected state, and this it wasn't present in 2G or 3G. Okay, DRX was only available in idle state in 2G or 3G. So there is additional power saving in 4G. Okay, but the gap now shouldn't be very long because to be cautious. Okay, because you don't know when the B again wants to send packet or resumes packet transfer. Okay, so after a short break, you should again turn on. Okay, but if there are no packets, you can again go to sleep mode. Okay, then okay. So these are called short cycles. Short cycles. After a few short cycles, if you see that no, there are no packets coming in, so why wake up? Because I mean here, if you had some packets, if the network found some packets here, okay, it would send when you wake up, it would send here. But when you woke up, you didn't find any packets. So that means that there are no packets actually. So you again go to sleep mode, okay, and then again turn on. Of course, if you find a packet, say a packet comes in here, then you no longer sleep. Okay, you will have to remain on. Where is it? You'll have to remain on, and packets will be probably coming in. Okay. So again, if there are some gap in the packet transfer, then you can start this DRX operation. Okay. However, if it is like you don't have all these packets, Okay, if you don't have all these packets, then what you may do after a few short direct cycles, before being a teacher, I should have gone to a drawing school. After a few short cycles, you can start actually long direction. Then after you find that there are no uh, packets coming in, okay, then you can go for a long direct cycle. Okay, and how many short direct cycles? These are short direct cycles. Okay, so this is a long direct cycle. How many short direct cycles you may use before you trigger the long direct cycle is set by the network, and it can vary between 1 and 16. Okay, so these are called short direct cycles, and this is called long direct cycles. Okay, and if say after waking up here in this on period, okay, in this on period, if you again don't find any packet, you again, I mean, you continue the long direct cycles. Okay, you go to sleep mode. So until you find a new packet, you keep to using the long direct cycles. The length of both short and long direct cycles are set by the network, and I say that the number of short cycles that you should use before starting the long direct cycles is also set, and the maximum number can be 16. Now, I mean, on this slide, it says that the direct cycle mode is actually equal to a paging cycle. Okay, there can be something called paging occasion. In I mean, in one cycle, how many times you can page? Okay, it's called paging occasion. We'll discuss paging later. Then this term you'll be familiar with. Okay. Now for I mean RC connected state, we first need to understand that the typical traffic pattern for many different applications are like this, that you have some intermittent transmissions. Okay, if you packets are transmitted, say you were probably discussing web browsing, yeah, web browsing. So you had some packet transfer, and you got a page from the web server. Thereafter, you read this page, and then again click somewhere. Okay, so then the transfer of some new packets will take place. Okay, then a new page comes in, you read the new page, and then again click somewhere on the page. Okay, so it will carry out transfer of some new packets. So this way, uh, in many different applications, you have some gaps in the packet transfer. Okay, so to take care of it, well, I mean, to fit in power saving, uh, this DRX operation is introduced in RC connected state for LT. Okay. The long and short DRX cycles are explained here, and the I mean, I said that the length for all of them, long or short DRX cycles, are set by the E node B, but uh, if you have a longer delay, then I mean there is a trade-off how long it can be. If you make it too long, if the direct cycle is made too long, then there can be delay in packet transfer, because a packet may be waiting for you, but the network is has to wait until you again switch on. Okay, so that causes packet delay. On the other hand, a longer direct cycle can be more power saving. So there's a trade-off between power saving and packet delay. In our RC ideal state, it's like trade-off between packet, I mean, call setup delay and power saving. Okay, and here, okay, maybe write down. Sorry. So in this ideal state, in the case of ideal state, the trade-off is between power saving versus call setup delay, because in ideal state a new call may be set up, whether it is a data session or voice call or whatever. Okay, in general we are just calling it a call setup delay. But in RC connected state, it's not call setup delay, it is packet delay, packet transfer delay. A packet may be may have come in, may have arrived here, and it is waiting for you, okay, until you again switch on. Or a packet may have arrived here, it has to wait this period until you switch on. So there will be delays in packet transfer. Okay, latency or packet transfer delay. Okay, so it's like packet, in short it is also called packet transfer delay, or in short it is called packet delay or latency. Okay, so versus power saving, that is the trade-off here. When you are RC connected, in RC connected state, then the trade-off is like this. Okay. Now finally there is a timer before you trigger. Okay, when you stop, when you find that there is no further packets coming in, you start a timer. When that timer expires, you start the short direct cycles. So there are three things: a timer which expires and you start short. This timer period is also set by E node B. Okay, and once it expires, you start short direct cycles. The length of short direct cycles, length of long direct cycles are set by E node B. My book explains which parameters is used for this sort of setting, and how many short direct cycles you need to run before you trigger the long direct cycles. So this is what is explained in the slides. Okay. If you go through them, you should. This is just an example about how, I mean, the different uh, states. Okay, that timer is called inactivity timer. Okay, you don't have any packet transfer, so the inactivity timer. So if you were in the middle, like in 2 minutes, I'll inshallah finish this class today. Say you stop temporarily. I mean, after this moment, you find no packets coming in, so you have started the inactivity timer. Okay, but the inactivity timer, before the timer expires, if you have found new packet coming in, then of course you cancel the timer. Okay, you start listening to packets, and once again you find a gap in the packet transfer, you restart the timer from the beginning. The timer has to be started. Okay. Questions? Questions? Okay, then I'll see you tomorrow in the class. Thank you for your time.